Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit where we're going to start doing some AMC 1012 problem review. We are getting close to the exams, right? We are 8 weeks away from the tests now for the 10A and 12A, which are on November 10th, and then the 10B, 12B will be the next Wednesday on November 16th. So those dates are coming up, and so during the time before those tests, we are going to do some practice problems here each week, a couple each week. If you're looking for some more tips, check out our blog at areteem.org/blog. We have a prep guide with some other tips, some other resources, places you can get some more mock exams, etc. that would be helpful before you take the exams this fall. But let's jump into our problems here. First question is with geometry, and we have a convex quadrilateral and some information given about it. So we have two sides of the quadrilateral. We know the diagonals are intersecting. We have these two triangles with equal areas. And some alarm bells should be going off when we look at these things. Some things should be suspicious with our setup. Now, I'm going to draw a diagram that should make you even more suspicious. And then let's kind of talk about what we know and what we can prove from this setup here. So we have our quadrilateral. We know that we have these kind of lengths 9 and 12. So let me label the top AB, and that's 9. The bottom CD is 12. Remember, we always order in a circular pattern there. We have our diagonal in this case. I'm going to ignore AC for a moment, and I really want to start with this important fact, and this is going to be the key idea of the problem, is looking at AED and BEC. And those have the same area in this case. Now, this should make us suspicious. This should remind us of a special shape with a trapezoid, right? And so actually, this does work in both directions. If we have a trapezoid, these two triangles have the same area, but actually that's enough to prove we have a trapezoid as well, right? So our key fact is that the areas are equal. So I'm going to use square brackets here. This implies that ABCD is a trapezoid, with AB is parallel to CD, right? And of course, the trapezoid fact is really this parallel lines. AB is parallel to CD, and we'll see that that is really what gets us the problem there as well. So I'm going to erase this when we're done, but right, this actually can be proven pretty quickly and is a useful thing to keep in mind. So, right, what is the proof of this fact, right? So the proof is that if AED equals BEC, then, well, what if we add CDE to both of those? Well, then the area of ACD is equal to the area of BCD. And this should be making us think of our same base, same height type of things, right? So these have the same base. They both have that base CD in this scenario. And so if we draw the heights down, right, we have a height here and we have a height here. Again, this is common trapezoid stuff. We have those two heights. Those things are equal. So, right, since they have the same base, they have the same heights, so AB is parallel to CD, right? This is really giving us our key fact there. Anytime you have two lines that aren't getting closer to each other, they have to be parallel there. So that gives us our setup, and that proves our key fact we have there. So like I said, I'm just going to erase that so we don't have it messing up our rest of the things here. But that is something you should at least be somewhat comfortable with proving yourself as well. Now, once we have this, things are pretty routine there. So since, right, so since AB is parallel to CD, right, we know that triangles ABE and CDE are similar. So we have these similar triangles in that case, right? Their ratio of sides, right, 9 to 12, which is 3 to 4 in that case. And this is really what we need. Why? Because that's AE and CE. Those are corresponding sides as well, right? Hence, AE to CE is 3 to 4. And since AC equals 14, this implies that AE is 6 and CE is 8, right? 3/7 of 14 is 6. 4/7 is 8. We don't need that second part because AE is 6 gives us answer choice E here. That is our final answer in this scenario. So geometry, be suspicious of some facts. That gets us to, we have a trapezoid actually, and things are nice from there. So let's look at one more in this video. This is a 12A problem involving logarithms and some probability in this scenario. Right, again, look at kind of key pieces of information and things like that there. So when we're reading this, the key note I want to make here, right, is that note we have all powers of 2. Right, and that's going to actually come into play and be pretty useful in what we do for this problem. So let's look here directly for a moment at our logarithm, right? So let's look at this log base A of B. That's what we're looking for here. And using this note, right? Using our note here that we have all powers of 2. Well, we're looking at log base A of B. And what we really care about are these powers of 2. So let's write these things as powers of 2. So let's say A is 2 to the mth power, B is 2 to the nth power. And so then when we write out this logarithm, we basically have log base A, which is 2 to the m. And then we have this is of 2 to the n there. Now, you could rewrite this with exponents to prove some of these facts, but let's remember our change of base formula. So this is equal to what? Let's change everything to base 2. And maybe this is a fact you are comfortable enough to do in a single step. If so, that's great. But we have log base 2 divided by log base 2 of 2 to the m. So that is our change of base formula. And note that when we do this, log base 2 of 2 to the n is just n, and log base 2 of 2 to the m is just m. So in fact, when we write it this way, right, we're doing this log base A of B, where A is 2 to the m and B is 2 to the n, we just end up with n divided by m in this scenario. So now we are ready to do probability, and we can phrase everything in terms of these A's and B's from here, right? So note, right, what we can think of is choosing from 1 to 25, right? So the problem is the same as choosing from 1 to 25. So that is all of our powers of 2. So we're rewriting it that way, right? And we want the probability that n divided by m is an integer. And so this is a little bit messy, we'll see in just a second, but it's not too hard in this case. So our probability is always 1 divided by total. So if you know me at all, you know I like starting with the total. One final caution here, n and m are different variables. So we are choosing them in order, right? N divided by m is different than m divided by n. So our total number of outcomes, there are 25 choices for the first and 24 choices for the second. That's what we want to be a little bit careful with there. Now, numerator, nothing special, but still a little bit messy. So what do we have there? Well, we have cases we can deal with, right? We want n to be a multiple of m to be a factor of n. Probably easier to do the multiple route. Think about what m could be. If m is 1, well then n can be any of the other 24 numbers, right? If m is 2, then we need multiples of 2 above 2. So we go up to 24, that is 11 other multiples we have. 3, we go up to 24, 8 minus 1, 7 other multiples we have. And then this is going to continue the same way, right? So for 4, we have 5. For 5, we have 4. And it's a little bit tedious, but we can just keep doing these all the way up until we get to 11, right? And notice that once we get large enough, right, this is actually not so bad, right? So, we can go up to 12 because 12 is 24. But notice that once we get up to 9, right, we only have 1. So let me save a little bit of space here. For 9, 10, 11, and 12, there are all only 1 additional 1 that we have. So let me say 4 times 1 in this case. And now it's just something you can calculate. This actually gives us 62 over, and sometimes one little tip, don't simplify things when you don't need to. Now we can divide by 2, we get 31 over 25 times 12, that's 300. So you don't need to simplify that. These numbers aren't too bad, but sometimes that can save you a little bit of time in cases. So final answer B, 31 over 300 here. Okay, that will take us to the end of this week's video. Thank you all for watching. Stay tuned for some new problems next week. Check out the blog as mentioned for other tips and tricks there as well. And share any comments, ideas, requests for future videos with us in the comments below. Goodbye, everyone.